This is section 3.2 of your MathLinks 8 book. This is on the introduction to Pythagoras. So the first question says, what is the missing number? And the reason why we're looking at this is because Pythagoras said when you take a right triangle, this leg here we call leg A, and this one here we call leg B, and this one here we call leg C, which is a special name called the hypotenuse. So legs are really the two sides of a right triangle that make up a 90-degree angle. Okay, so we call this a leg and a leg. And this one here, because it's not making up the 90-degree angle, it's actually adjacent to the 90-degree angle. This one has a special name. It's called the hypotenuse. And what Pythagoras reasoned was if you attach squares to all of the sides of a right triangle, he found that the area, and this, since the side length is a, the area would be represented by a squared because we square it to get the area. And b, if we square that area to get the square, you add a squared and b squared together, or the area of the squares attached to leg a and b together, you will always get this area here, which is known as c squared. So Pythagoras reasoned that the area of the two squares attached to the legs of a right triangle will always equal the area of the square attached to the third side, called the hypotenuse. So in this particular drawing here, it tells us that this is a 90-degree angle, so we have right triangles. It tells us that this area of this square is 20 square centimeters, and that this one is 32 square centimeters. So therefore, since it is a right triangle and the Pythagorean relationship is about right triangles, this one must have an area of 52 centimeters squared. Pretty simple. In the next question, however, too many people got it wrong. Because if you look at this one, if I was to draw a red line on the legs, this is a leg and this is a leg, because there's my 90-degree angle. So those two red lines are legs. And if I drew a green line, this green line here would be the hypotenuse. So the area of this square plus the area of this square equals the area of this square. So therefore, it's what number plus 25 equaled 90? Well, the easiest way for us to do that would be actually to take 90 and subtract, because I can actually think of this as a variable, subtract 90 from 25 to get 65, and therefore x would equal 65, or the box would equal 65. So therefore, this area has to be 65 centimeters squared. How many of you put 115? Don't lie to me, because I know you exist. Nobody. Amazing. I have the smartest class ever. Now, in this particular question, this is a leg and this is a leg. So this area plus this area will equal this area. And that's a pretty easy question. So therefore, the missing area is 676 millimeters squared. There are your vocabulary answers. Now, the first one, the only one that we don't really know, is this one right here, and I'll just highlight it for you. The Pythagorean triple of 3, 4, 5. Now, what this means is Pythagoras realized that there was a ratio of side lengths, that if this was 3 and this was 4, so the legs were 3 and 4, if I was to attach squares onto all of them, this would be 9, this would be 16, and this would be 25, meaning the hypotenuse length would be 5. So we called it the Pythagorean triple because 3, 4, 5 is a basis for any ratio that you want to have for sides. So if I was to multiply the 3, 4, and 5 by 2, I would create a new triangle that was twice as large. It would be 6, 8, and 10. And I would look to see if that would work by attaching squares here. This would have an area of 36, this would have an area of 64, and this would have an area of 100. But you can do that with anything. You could actually take that right triangle and, using the Pythagorean triple, take your 3, 4, and 5 originally, and let's say multiply by 1.2. This is a grade 9 version of the question, but we'll just use it anyway. So we'd have 3.6, we'd have 4.8, and we'd have 6 here if we multiplied them all by 3 point. And if I attach squares onto these and thought about the areas, I could take my calculator and go, oh, take my calculator over here. 3 point, hang on a second. 3.6 times 3.6. This would have an area of 12.96 meters or whatever they happen to be squared. This one would have 4.8 times 4.8. That's not 4.8. 4.8 equals 23.04. And if I add that to my other area of the leg, 12.96, I would still get 36 here. And its square root is 6, so it still works when you multiply the Pythagorean triple by any number, as long as you keep the ratio of sides consistent. So that's called the Pythagorean triple. Question 4, is that the last question? Question 4 gave you a fairly complex looking question, but it's not so hard. The first thing we can figure out is what is the area of this square, x. So this is a leg, and this is a leg, and this is a hypotenuse. So this area plus this area will equal this one. So therefore, I know it's going to be 28 meters squared. And once I know that's 28 meters squared, I'm going to actually take my marker here. I'm going to erase this. And I'm going to put 28 in there. So now that we know that, we have another right triangle over here. This is a leg, and this is a leg. So this number plus this number gives me this number. So therefore, y must have an area of 16 meters squared.